Okay, the first one of these we're going to look at is where we've got two vectors at a right angle, two forces at a right angle, and we're going to be looking for the resultant force. So you've got to think about what is actually happening here. So if you've got an object which is going to be starting in this corner where the two forces are coming from, it's being pulled with 10 newtons this way and 8 newtons this way. So 10 newtons to the right, 8 newtons down. Now, you've got to think what would happen to that object. So you are going to get essentially a resultant force going somewhere over here. We've got to work out exactly where that is and exactly how big that resultant force is going to be. So, to work that out, rather than taking this as, oh, it's being pulled this way and this way at the same time, it's much easier to think, right, it's being pulled this way and then this way. Okay, so I can transplant this force here straight over to here. Okay, so if I do that, I've got a force here of, a size of the force in centimetres is 2.8 centimetres. So I'll draw a line straight down, 2.8 centimetres down there. And to check it, I can do the same with the top one, 3.5 centimetres to there. Okay, so something like that. So instead of being pulled that way and that way, it's being pulled 10 newtons that way, then 8 newtons down. So that will give us a resultant force straight across the diagonal there. Okay, and make sure you put the force arrow on there, so I'm showing which direction that's moving in. I could even put it in the middle to make it really clear. Right, so that shows where the force is in terms of, I've drawn it on the diagram. But we want to work out, because it's a force, it is a vector, which means it's got a size and a direction. Okay, so to find the size, if I know that this one at the top is 10 newtons, so I know that 10 newtons, okay, I'll move this over a bit, is equal to 3.5 centimetres. I want to know how many newtons are equal to 1 centimetre. So I'll divide the 10 by 3.5. So I'll do 10 over 3.5. Okay. And that will give me an answer of 2.86.86 newtons per centimetre. So I know every 1 centimetre is worth 2.86 newtons now. I've found out what the scale is. So back to this. If I know that every centimetre, is 2.86 newtons, if I measure the length of this vector in the middle, the length of the resultant force, taking that as 4.4 centimetres. So I'll do, that's 4.4 centimetres, okay, and then do 4.4 times by my 2.86, okay, and that'll give me my size. So that's 12.6 newtons. That's my answer. Now the direction, I'm going to have to use a protractor for this. So I'm going to measure from the horizontal. Now it's up to you where you measure from. I could measure from the vertical, I could measure from the horizontal. So if I measure that angle, that is, let's say that's 38 degrees. So it's 38 degrees from the horizontal. Okay, so I've measured the size of the force by measuring the length of it. I've worked out my scale over here and then found then times those together to work out how big the force is, and then the angle, I've just measured this angle here from the horizontal. Again, I could equally measure from the vertical instead to find the size of the angle.